Okay, so on the day you missed with our guest speaker, they were from Southwest Research Institute, and they were walking us through an activity to talk about lean manufacturing. So, just a little bit about Southwest Research Institute is they are benefiting the government, industry, and public through innovative science and technology. So they have lots of different departments, and they run different tests or different experiments, or they'll help other people make things better or something that they're looking for their company. Today, we're going to talk about mostly their manufacturing area. So every company is driven by quality, cost, and delivery. Quality is now given in the marketplace. So if you order from Amazon, you want that item now, like ASAP. So customers demand this shorter lead times. Customer loyalty and retention is critical. So you want to keep your customers. Otherwise, they'll go somewhere else where they can get it quicker, faster, cheaper. So that also talks about the price pressure of lowering costs. And then lower invested capital. You're getting more output with less. And so that's kind of what we're going to go through today. What is lean? So the definition of lean is a systematic approach to identifying and eliminating waste, non-valued added activities through continuous improvement by flowing the product at the pull of the customer in pursuit of perfection. Okay, so we're going to walk through that. Okay, so the activity that you missed today, we're just going to walk through it and kind of talk about it because you can't do it. But basically, we are going to do a short version of what they would walk through an orientation of a company to try and make their process more lean. So we're going to pretend that you're hired. This is your orientation. You're getting started on your training. And we're going to be a module aerospace enterprise. And so welcome aboard. You are all new hires. Okay, a little bit of background is this company was started 30 years ago by two Air Force vets. The company makes small jets and planes from module components, where increasing customer demand is currently causing many problems. Current management is very traditional, old school in their thinking. Okay, all of our shifts are 7 minutes in length. We're going to work in batches of 5 planes. So you have to have 5 planes before you can move it to the next station. You must always keep busy, but you cannot help each other because if you help somebody in their station, you're going to get behind in your own station. And so we want to make sure everybody is in their own station. If for some reason something, you end up with a plane part and you're just not sure what happened, it's not the way it's supposed to be set up, you're going to flip it upside down because we're not trained to rework that. And then know the boss is always right. Okay, so in this activity, we had everybody in class do a different workstation. So we had station 1, they were in charge of the main body of the plane. Station 2 added the wings of the plane. Station 3 added the tail. Station 4 added the cockpit and wheels. And Station 5 is our final inspection of quality control, making sure that the plane is correctly put together. We had some raw material handlers, and so they would come from the warehouse and bring the materials you needed for your station. And then we had a plane material handler, and this was our forklift operators, and they, again, could only bring 5 parts from each station. So when 5 main body were done in workstation 1, they would bring those 5 to station 2. So round 1, we are going to, again, do this traditional manufacturing style. So remember the rules. All shifts are 7 minutes in length. We work in batches of 5 planes. So you cannot ask your forklift driver to move your planes until you have 5. You must keep busy at all times. Workers cannot help each other. Again, if something's wrong, you need to put your plane upside down because you're not qualified to fix it. Okay, so what we did in this activity, just to show a little bit of pictures, is we had students, again, go from one station. They built the body. Once they had 5 planes, the forklift driver moved it to station 2. And then from station 2, They built the wings. Once the wings had 5 planes together, they moved it to the tail. And then from there to the cockpit, again, 5 planes at a time. Okay. The goal is to get 30 planes in a shift. We had 7 minutes to do this. When this happened, we saw a lot of lost time. So again, let's debrief a little bit about what happened. So when this happened, the process just wasn't as great as we wanted it to be. The fact that we had to wait for batches of 5 took Station 1 was pretty quick because they only had 2 pieces to put on their plane. But when it got to Station 2 and 3, there was a lot of wasted time. And so Station 4 and 5 were waiting forever to get that first batch. So batches is not really working out for us in this company. And so we want to kind of come up with a better idea. And that's why we're hiring Southwest Research Institute to see if we can come up with a better way to do this. Our layout also wasn't fantastic. Our layout, we had all of Station 1 in one section, all of Station 2 in another. And so we had to have the forklift driver going back and forth quite a bit. And then the materials themselves were in the warehouse. And so the material handler had to go back and forth as well quite a bit. So the layout of our production line was just not very good. And so in general, there was just way too much work that was just in process, right? So we had a lot of work in process. And so what happened is after those 7 minutes, we did not meet our goal of 30 planes. In fact, we only really had about 5 at the end, okay? And so our customer is very upset because we did not hit those 30 planes. So let's talk about why Southwest Research Institute can help us. So we want to have value added. So these are the next steps. We want steps essential to deliver the product or service according to the customer. So the customer cares what the customer is willing to pay for, right? So if there's value being added to the plane, then of course the customer wants to pay for that. They do not want to pay for that extra time wasted, the non-value added. So the steps that didn't generate any value from the customer's perspective, they don't want to pay for that. And so we're paying these employees extra, but there is a lot of non-value added time between transportation and materials, and this can be eliminated or reduced without impairing our process. And so we want to look at the process and see how we can better it. So we have a non-value added but necessary. So there are some steps that are non-value added, but we do require them. So we need to make sure that we do have safety and regulations, and we also need to make sure we have quality control inspecting all the planes. In general, we need to step is our non-valued items added unless a strong case can be made. Otherwise, we need to show that it is value added to our customer. So if we look at this pie chart here, when we just did our activity in class, about 95% of the time was non-value added. And so the problem was we had some defected planes. We had overproduction in some of ours. So in Station 1, they were producing very fast, but it took a while in Station 4 because Station 4 had to add more pieces. So there was a lot of waiting going on as well. The transportation part, again, having to move in batches of 5, we had a problem because we had to move the forklift from one station to another, but we couldn't move it until there were 5 planes on each station. And then inventory was really far away, so that was also a problem. And then just motion, there was not a very good flow going on. So when we look at this, there's 2 improvement approaches that we can do. Option 1 is focusing on the value added reduction results and minimal improvement. Well, that's not really happening. Everybody in the station was working. Okay, so when they got the plane, we do need those people to still assemble the plane. So what we really should do is option 2, where we're focusing on that non-value added. How can we reduce things that are not significant in making the planes? So there's a lot of different building blocks that we can use to help us continue improvement in our plane making, okay? So we want to look at different things. Can we standardize work? Can we visualize? Can we plant? Can we lay out the plant better? Can we figure out if we can reduce the batches? And instead of having to wait for 5 planes, is there a way to just do, once I'm done with one, I move it to the next station right away? So since we're in math class, let's talk a little bit about math. And so the customer value added time is the amount of time that it's actually taking us to make the plane, right? And so when we were talking to our different workstations, we came up with basically each station 1 was just 1 or 2 seconds, station 2 took a little longer. But when we added all the stations together, for them to make one plane in their station, it only took an average of about 17 seconds. So the question was, why did it take so long, almost 5 minutes, to get our first full plane out if building a plane was only 17 seconds? Well, part of that was the wasted time and the batch, having to wait for the batches of 5. And so the customer value added time really is that 17 seconds. And the amount of time it took us to get out was 5 minutes. If we convert that to seconds for our formula, then we have seconds, about 300 seconds on the bottom. If we divide that, we're only at about 5.6%. And so 5.6% is the process cycle efficiency. So it's not very efficient in that we have all this wasted time and it took us that long to just get one plane out, okay? So the performance indicator is how effectively the process is converting into the work in process and all the way to the exit point. Okay, so again, what is process cycle efficiency? We kind of went over it. Our example here is another one. It takes process 1, process 2, process 3, and then the exit rate. And so we can come up with this formula to really see how much value added time we have. So if we look at the efficiency benchmarks, no one's ever going to be at 100% because there is going to be that time where we need to do quality control and safety checks. And that is not adding to the plane or the customer's product, but it is essential and we can't get rid of it. So you're never going to be at 100%. Now, if we look at assembly with our batch transfer, okay, we just said that we were about 5.6%. If you notice on this chart, the low end is about 15%. So we are very below that from our experiment, okay? And then you'll notice the high is 35, okay? Again, no one's close to 100 because we still need to do these other pieces, but definitely higher than 5.6%. So let's talk about a way to reduce this. Well, one way is we could reduce the batch size. So instead, if we look at this process, it takes 10 minutes for process A, 10 minutes for process B, 10 minutes for process C. And if we do it as a batch, it's going to take us 30 minutes for this whole order, with 21 minutes being for the very first piece that's completed. Well, if we change this process to where they're right next to each other, and instead of waiting in batches, we can just move it from process A to B to C without having to wait, then that's going to put us at 12 minutes. And so this is the idea that we really want. And just like the Toyota video we watched, the assembly line is a lot faster, and you don't have to wait for a batch of 5 planes or 5 trucks in their case. Okay, another thing about math when we're talking about this is takt time. So this is the demand rate. We want to think of a drumbeat or a pulse, right? So what is the work time that's available? Okay, and what's the quantity units demanded by the customer? Okay, so for us, ours is 7 minutes. That's our work time available right now. And the demand of the customer was 30 planes. And so that is the takt time. That's an equation that we can come up with. And our goal is to produce that for the customer to get their demand. So 7 minutes divided, and we could do that in seconds if we needed to. So 7 times 60 would get us our seconds. So go ahead on your piece of paper, go ahead and do that. 7 times 60. That's going to go in the numerator, divided by the 30 planes. We should be able to produce a plane every 14 seconds. That's what you should have gotten from this, okay, based on our experiment. Well, now we need to see how many operators we really should need, okay? So if there's a cycle time versus our takt time, okay, well, we said our cycle time was 17 seconds. That is very, very short. It said it took 17 seconds to get a plane. Maybe it was a little bit longer, but let's go with what y'all said. So 17 seconds to get one plane completely together, divided by our takt time, which was 14 seconds. So 17 divided by 14 is 1.2. So really, we should have only needed at max 2 operators. And instead, we had lots of operators. So what is going on? We just need to make our system better. Okay, so our process lead time, again, the time from the release of the product into the process until its completion. Now, work in progress, we also want to reduce that. So for the people that were here, there was a lot of work in progress, meaning they had a lot of pieces just laying around waiting for it to be transported to the next station. And so if there's ever an issue with a product or it just sits there, that's money wasted as well. And then the exit rate was the amount of time it took to output the process. Okay, Little's law describes the relationship between these. So the work in progress with the process lead time and the through output. And so we again have this other formula here where we can put the work in progress, which is called WIP, and divided by the exit rate. And so again, making this a lean process involves our math. So let's go ahead and do another one. So this time around, the students in class got to change what was going on and make it better. So again, just refreshing on what the problems were. We had this problem where we had to wait for batches of 5. Well, in this case, now let's just move it as one plane at a time. And then the layout was really bad. We had workstation 1, they were all together. Workstation 2 was all together. In this case, we're going to actually have multiple stations where we can have different colored planes. Maybe we have blue, red, white, and black planes. And so we can actually produce more because if we put everybody next to each other. So workstation 1 would hand over right away to workstation 2. There will be a queue in between every workstation, and you cannot move any more products until that queue is empty. This will help the WIP, the work in progress, and so we're not leaving money or materials just lying around. So again, we're going to have workstation 1 right next to 2, right next to 3, right next to 4, right next to 5. And so the process will be very simple because we will not have to transfer the planes. We're just moving them along the assembly line. We're also going to have the materials right by them. So instead of having the materials in the warehouse, we're going to move the materials right to the stations. And so that will save a lot of time because we will not have to have materials going back and forth. So the people that were the forklift drivers and the material handlers, they're not out of a job. We're just going to move them to the other assembly line. And instead of just having one type of plane, we can have multiple types of planes now. And so we can have the red and the blue, and they don't lose a job. They just get reallocated to a new station. Okay. And then also the other thing we talked about was the workload. So station 1, for example, only had to put 2 pieces onto the plane, where station 4 had to put like 6 pieces. So we're going to reallocate the process as well, where it's a little bit more even. And so station 1 is going to have to put 4 pieces on, and station 2 will have to put 4 pieces on. And so it'll be a little more balanced. Okay, so let's rework this problem and see what happens. So in class, they did this, and it was really beneficial. In fact, majority of the people got over their 30 planes. Our highest assembly line in 7 minutes was able to produce 38 planes. Okay, so that is now way better because we met the customer's demand and we were able to create different planes while at it. So again, Southwest Research Institute helps these companies try to figure out a way to become faster and more efficient for their customers. Because again, if we want our Amazon order ASAP, people also want their planes ASAP. Okay, I would like you to go ahead and look at the pictures from the example and fill out the questions as best as you can. If you have any other questions, you can go to the Southwest Research Institute website to fill out your exit ticket as well. And then a fun Thomas Edison quote, "I have not failed. I've just found 10,000 ways that won't work." And so with that, thank you, and we'll talk to you soon.